Hello students, hope you all are fine. So yesterday we were doing to find out the numerical differentiation using forward difference formula. Today we will again find out the derivatives but using backward difference formula. So as you all know that Newton's backward difference formula is this one: y is equals to yn plus p delta yn plus p into p plus 1 over 2 factorial delta square yn plus p into p plus 1 p plus 2 over 3 factorial delta cube yn plus so on. So as we did yesterday, we will again find out the derivative of this formula with respect to p, because it's clearly shown in the formula that here y is a function of p. So we have done this derivative with respect to p. Now we also know that p is equals to x minus xn over h in case of backward difference formula. So here p is a function of x. So we have taken the derivative of p with respect to x. The derivative of this term with respect to x will be 1. This is constant, so its derivative will be 0, and this h is as it is. So now dy over dx will be equals to dy over dp into dp over dx, that is equal to this formula. Now we have to find out the derivative at point x equal to xn. So if we put x equal to xn in this formula of p, the p will become 0. So at p equals to 0, this formula will reduce to this one. This is our numerical differentiation formula using the backward interpolation formula. Okay, now similarly we can find out the formula for the second order derivative and third order derivative in this way. So these are your all formulas to find out the derivative using backward difference formula. Clear? Now as we did yesterday the question using the forward difference formula, today we will do the question using our backward difference formula. Now this question is given to you: find the value of cos 1.86 from the following table. Now how you will get to know that you have to apply the formula of forward difference or backward difference? Look at the value at which you have to find out the derivative. If the value lies below the center, you will apply your backward difference formula, and if this value lies above the center, then you will apply your forward difference formula. So here the value is 1.86, that is lying below the center, so we are going to apply the backward difference formula. Now in this question you can clearly clearly see that there is nothing given that find out the derivative. The term derivative is not given, right? So you can check that here these are the values for x and these are the values for sin x, and here it is given to find out the value of cos. We know that the derivative of sin theta is cos theta, so clearly this is the question to find out the derivative. So to start with the solution, here we have made the backward difference table using the values of x. This sin x is our value for y, so these are the values for y and all the differences. Now in the case of backward difference table, this is our value xn, this is corresponding value yn, and these are the values we take in case of backward difference formula. So we have to find this cos 1.86, that is y dash, the derivative of this y is equal to sin x. So that is we have to find out the derivative of this y at point x equal to 1.86. So applying this formula, we will put all these values here like delta yn. Delta y, this is the value for delta yn. In case of delta square y, this is the value for delta square yn, and so on. By putting all these values here, we got the value for the derivative. So this was all about to find out the derivatives using backward difference formula. Hope you are studying well at your home. Keep practicing and keep preparing for your finals. Thank you, students.